Okay, in this video we are doing some more review. We're going to be looking at specifically exponents and then exponents as they are used in scientific notation. And finally we'll look at order of operations, which also can involve some exponents. First off, a definition of exponents. An exponent is really just a short form of writing common or the same numbers or the same product. Like if I have 2 times 2 times 2 times 2 times 2, rather than having to write all that, I can write that as an exponent. So I write down what the common base is, it's a 2, and then as an exponent I write how many 2's I have. So in this case there were 5, so I write it as 2 to the 5th power. This doesn't mean 2 times 5, it means 2 to the 5th exponent. Or in other words, 2 multiplied by itself 5 times, like I've shown there. Now, when we have exponents, there's lots of rules and things that we can use to manipulate them. So we could divide bases with exponents, multiply, etc. Okay, a couple other little rules or properties with exponents before we get really going with them is that anything to the 0 power is equal to 1. So a to the 0 is 1. If I have 1 to the 0, that's 1. If I have 10 to the 0, that's 1. If I have star to the 0, that's 1. So anything with the exponent of 0 is equal to 1. Also, and this is one that we use lots, is if I have a negative exponent, I can make the exponent positive by putting it to the other side of the fraction line. So if I have a to the minus m, that's the same as 1 over a to the positive m. Or if I had 2 to the negative 3, that's the same as 1 over 2 to the positive 3. Or if I had another sort of a similar case, if I have 1 over 2 to the minus 4, for example, in this case the exponent is negative, it's on the bottom, I can move it to the top, up to the top, so it would be like 1 times 2 to the positive 4. And 1 times 2 to the positive 4 is just 2 to the 4th. So if you have an exponent that is on the, if you have an exponent that's a negative number, you can move it to the other side of the fraction line and make it positive. So here's a couple little examples. So, and maybe try these. Press pause, then press play after and see how you do on them. Answer this. It's to the 0 power 1. 0 power 1. I have a negative exponent, so that's the same as 1 over 9 to the positive 2. If I wanted to simplify this all the way, I could leave it like that, but probably it'd be best to figure out what 9 squared was, and that's 81. Here's another one. I have 2 to the negative 3 on the bottom, so I'll move it to the top and make it 2 to the positive 3. Again, like this one, I can simplify that. 2 to the power of 3 is the same as 2 times 2 times 2, or if you multiply those together, 8. Okay, so if I have an expression that involves lots of negative exponents, if I have this situation here, I can just move things around like I said on the last slide to make things positive. So the c squared is positive already, so it stays put. But the a to the minus 4 is negative, so I'll move it to the bottom and make it a positive 4. The b to the minus 5 is negative on the bottom, so I'll move it to the top and make it positive. Okay, try that one. Okay, the 3 has an exponent of positive 1, so it stays. X squared is positive, it stays. Y to the minus 4 is negative, so I'll move it to the bottom. Z to the minus 9 is negative, so I'll move it to the top and make it positive. Okay, hopefully you're getting the idea with those. So those are just some basic things you can do with exponents. Now let's get into doing some operations with them. And so that's where these rules come in. So if I have common bases and they have exponents, I can simplify that or combine that by adding the exponents. And that's known as the product rule. We'll see that lots. There's similar kinds of rules in logarithms and other places too. If I have an exponent that's raised to another exponent, this is the power rule, you multiply those exponents. If I have a product inside brackets that's all raised to an exponent, then each factor inside those brackets also gets raised to that power. So let me just give you a quick example of that. So say if I have 4 to the third times 4 to the second, the bases are the same, so I leave the base the same and then I add the exponents. Power rule, if I have 4 squared and then all that's raised to the third, then I multiply those exponents, so that'd be 4 to the sixth. If I have, say, 4x squared to the third, then here's two factors inside of brackets all being raised to the third, so that's the same as 4 to the third times x. Okay, this would be a power of a power, just like this rule, so I multiply those two, so that'd be 6. With this first one, 4 cubed, I'd probably simplify that out, so it's 4 times 4 times 4, or 64, x to the 6th. Couple last rules. Quotient rule, dividing common bases, subtract their exponents. So if I have x to the 9th divided by x to the minus 2nd, I need to subtract the exponents. Careful with this one, it's a negative sign, so it would actually be x to the 9 minus a negative 2. Notice the two negatives there, so that would be x to the 9 plus 2, or 11. Also notice you could have done this a different way. If this is negative, I could have just slipped it to the top and made it positive, right? Instead of being on the bottom. Then this is multiplying same base, add the exponents. You get the same thing. And then the last rule, I think, is where I have a quotient inside brackets that's all raised to an exponent. If I have that, each thing inside gets raised to that exponent. So say I have y to the 4th over z to the 3rd, all squared. So this 2 gets applied to each of those, and it's sort of like that power of a power rule. So it'd be y to the 4 times 2 is 8 over z to the 3 times 2 is 6. Notice I'm thinking that, hey, maybe I can combine these, but they're different letters. One's a y, one's a z. I can't use the quotient rule up here just to subtract their exponents because the bases have to be the same. Here's a couple you could try. Same base, add exponents. R to the positive 4. This is a product. So I have a product in here raised to an exponent. What do I call that rule? It's this one, raising a product to a power. So in this case here, the 3 would get raised to the second power, and the x to the 4, the negative 4th, would get raised to the second power, so that'd be x to the negative 8. Simplifying that, 3 squared is 9, x to the minus 8. But here I have a negative exponent. Typically I like to make those positive. So I would rewrite that as 9 over x to the positive 8. This would be the preferred answer on a test. Okay, a couple more. Okay, this is an interesting one. So 16 over 24, I could simplify those just as I would with a fraction. So 8 will go into 16 twice. 8 will go into 24 3 times. So I've just simplified those numbers. Then I have common bases, and I'm dividing, so I subtract their exponents. That'd be a to the 7th. That'd be the answer for that one. Okay, here's one that's a little bit different. We haven't really seen this rule. Good time to look at it though. If this rule is very much like this one, right, was it that one? Or this one, where I have things inside, and so everything inside gets raised to that exponent. The difference in this one is that this is a negative number. One real nice thing that you can do with this is, and it's similar, I guess, to that rule that we looked at right off the start, where if something's negative, you can flip it to the other side. So if all of these things are going to be this negative, why don't we flip them all over to the bottom, and we'll flip this one all over to the top, and we'll just change that sign. So that's the first thing I'm going to do, is I'll write this as 8z. I might have to do more moving later, but I think this is the fastest way. Over 36x to the minus 7y squared, all to the, notice all I did is wrote everything on the bottom and the top flipped, but I kept the exact same thing, I just moved it to the top. and take this exact same thing, move it to the bottom. But now this is a positive 2. So now I can take everything inside and raise it to that power. So 8 squared would be 64. Ooh, that's a big number. Oh, maybe I should simplify this first. This is in brackets, so I can do that. So 4 will go into 8 twice. And I'll just write my letters there. And 4 goes into 36 9 times. X to the minus 7, y to the positive 2. Okay, all to the squared. Okay, now let's take that 2 and apply it to everything. So the 2 squared will be 4. Z to the minus 3 times 2, so I multiply those, so that'll be Z to the minus 6. I'll have to fix that later. 9 squared is 81. X to the minus 7 squared would be x to the minus 14th. Y squared squared would be y to the 4th. Ooh, that's quite a bit of simplifying. And I don't think I'm done yet. So here I've got a negative exponent, another negative exponent. We know how to work with those. Let's flip this x to the minus 14 to the top and make it positive. 81 stuck there. Z to the minus 6 is negative here. Let's move it to the bottom and make it a positive 6. The y to the 4 is positive, so it just stays right there. So this would be my answer right there. Notice these aren't same basis, so I can't do anything with them. I'm done there. Okay, so that is some rules for working with exponents. One great example of using exponents is scientific notation. And it's a tool that we use to express very large or very small numbers. Very large ones would have positive exponents and a big number, and very small ones would be negative exponents. Scientific notation is always written in this format, where you have a number or a decimal multiplied by a power of 10. And we use power of 10 because our number system is based on base 10. Also note that n, this number here, has to be in between 1 and 10. It has to be less than 10, and it has to be greater than or equal to 1. So I could write something like 2 times 10 to the 4th. That's not very big, that's only like 20,000. Or maybe another one, 2.43 times 10 to the 109th. That would be a fairly big number. Anyway, that's an example of a scientific notation, and notice the exponent in there. So what we need to be able to do is to take any number and convert it to scientific notation. To convert it, what you're looking for is wherever the decimal is, you have to move it so that your first number is 1 point something or 2 point something or 5 point something, where you just have one number, one non-zero number out front. So in this case, I'm just going to rewrite this again. 1, 2, 800, 2, 3, 4. So 12,802,234. So the decimal point currently sits right there. And I want to move that decimal place so it winds up right behind the first non-zero number. So I want it to be 1.2800234. That's where I want that decimal point, is right there. But I can't just change that number without, fixing it or accommodating that change of decimal places. And so the way you do that is just go times 10, and then as the exponent here, you tell it how many times you had to move. So I had to move it 1 place, 2, 3, 4, 5, 6, 7 places. So my exponent there would be a 7. Now this is fairly long, and these numbers at the end here really aren't that significant. You might round that number to 1.28 times 10 to the 7th. In chemistry, we would have exact rules on how many decimal places you'd have to have. So it's a fairly big number. Now the next one, here this would be a very small number. But I do the same thing. I move the decimal so it's right behind the first non-zero number. So I'm going to have to move this 1, 2, 3, 4, 5, 6, 7, 8 places. So my number now will change to 5.9. Okay, so that's 5.9 times 10. And now I say how many places I had to move it. There were 3, 6, 7, 8. 8 places. Since it's a small number, since I was moving the decimal left, it would be negative. Okay, so that's scientific notation. Really useful, especially in sciences. We're always dealing with very large or very small numbers. So using scientific notation is handy. Now, if we go from decimal notation to scientific, we also need to go back the other way. I always had a hard time remembering which way I was supposed to go, left or right with these. But since I've started thinking about big or small numbers, it's not that hard. Here, this is a positive number. It's a big number. So the decimal has to move to the right to make this a bigger number. So I'd move the decimal 5 places. 1, 2, 3, 4, 5. I'm going to have to slip in some zeros there. So my number would be 1, 4, 5, 9, and 2 zeros, and then my decimal point goes right there. So my answer is 145,900. This is a comma, not a decimal. This one, negative number, so it's small. Therefore, I'm going to move my decimal to the left. So I'll move it 3. So 1, 2, 3. I'm going to have to put 2 zeros in there. So it'll be 0.0083. That would be this in decimal notation. So it's scientific notation. Useful to be able to convert to it or from it. Here's a couple questions where you can compute these. Like in physics or chemistry, we'll often be dealing with scientific numbers. We'll have to multiply these. It's not a bad idea just to be able to work these on your calculator. On your calculator, look for a button like an EE or an EXP, either of those buttons. And the way you do it is, instead of writing or typing in times 10, you replace that with just this EE button. So on your calculator, you'd go 2.3 EE 3. And then, so that would be for the first part. And then for the second part, you'd go 1.5, hit that EE button, and a -5, and then see what it comes out to. It's going to come out to 1.5, so 2, 3 point something. I don't know what the something would be, times 10 to the -2. I get -2 here because 10 to the third, 10 to the -5, common bases, and I'm multiplying, so I add their exponents. 3 plus a -5 gives me a -2. But you do that on your calculator. Same thing with this one down here. When you divide those, do it on your calculator. 1.1 e -40, divide 2.0 e -71, and it'll come out to something. It should be your answer in the end. I don't have my calculator with me, but it'd be 10 to the 31, I think, here. So this would be about 1.1 would be about 0.6 or something. So this, I'd move it 1 to the right. So it'd be, I don't know, 6 times 10 to the, if I move that to the right, I think I have to take a 0 off that, so it'd be like 30. Something like that. But use your calculator and you can figure that out. Okay, last thing in this section is looking at order of operations. Hopefully this is something you've done lots before. I'm not a big fan of BEDMAS, although it's nice to remember what those are. But really, the D and the M, it's whichever comes first. And the A and the S is whichever comes first. So I'd probably prefer to write it as B, do everything in brackets, then exponents, then divide or multiply, whichever comes first, and then add or subtract, whichever comes first. Okay, so let's just try a couple. So I've got to do brackets, exponents, then divide or multiply, whichever comes first, then add or subtract, whichever comes first. Inside, here's some brackets, so I need to do that first. So 6 take away 2 is 4. Okay, I'm dying to go 4 times 4, but the rule says after brackets do exponents. So I have to do this exponent first. So 4 squared is 16 times 4 minus 12. Again, I'm dying to go 16 minus 12, but the rule says to do divide or multiply after you've done all that stuff. So here's a multiply. I need to do that first. So 4 times 16 is 64. Take away 12, that's a subtract. Take away those, and that'd be 52. proper way to write this is make sure you put an equal sign in front of each one of those, because this is the same as this, etc. 52 would be my answer. Let's try this one. And maybe pause and try it on your own, then see how you do with it. So I've got a fraction line here. Putting a fraction line in there is really like putting brackets around everything on the top and putting brackets around everything on the bottom. So you need to do everything on the top first, then everything on the bottom, then you can divide the two. Okay, so let's start with the top. There's some brackets here, let's do that. So 10 divide, 8 take away 6 is 2, plus 9 times 4. Okay, on the bottom, we'll do that separate. 2 to the 5th, I think, is 32, plus 3 squared is 9. Okay, let's go up to the top again. I've got a divide, an add, and a times. So I do whichever divide or multiply comes first. Divides first, so I'll do that. So it'll be 5 plus 9 times 4 all over. This one on the bottom is on its own, right? It's sort of like in brackets, so I'll just add those now. So that'd be 41. Okay, now on the top, I've got 5 plus 9 times 4. I have to do the times first. So that'd be 36 plus 5 on the top. And I have 41 on the bottom. 5 plus 36, it's 41. Divided by 41 will be equal to 1. So my answer is equal to 1. Okay, hopefully that helps you out. Now, with all these, try some and make sure you practice this so that you're comfortable with these concepts, because we'll build on these as we do different concepts going forward. Oh, here's some questions that you can try from the textbook.